So if you read through job postings of data scientists and data engineers, you find overlapping areas, skills, and education. So in fact, a company's goals for the two positions can sound similar, right? Now, sometimes a job posting presents confusion over, for example, what a data scientist does or what the company needs to solve its data problems. Now, job posting qualifications like Python and SQL, for example, can also appear for both data scientists and data engineering roles. Now, because of these roles are continually used and molded, the line distinguishing between data scientists and data engineers is often blurred. So in this video, I'm going to clarify once and for all what a data scientist versus data engineering. So data scientist cleans and analyzes data and answers questions and provides metrics to solve business problems. Whereas the data engineer, on the other hand, develops, tests, and maintains data pipelines and architectures which the data scientist uses for analysis. Now, a data scientist and engineer play a distinct but complementary roles in the field of data analytics and machine learning. Let me give you a breakdown on the key differences between the two roles, and I'm going to give you examples also. So first, the responsibilities of a data engineer. Let's focus on design, construction, and maintenance of the infrastructure necessary for data generation, storage, and processing. Now, they're responsible for building data pipelines, data warehouses, and ETLs, extract, load, transform. And these processes to ensure data is cleaned and made accessible to data scientists for analysis. Now, data engineers often work with large-scale distributed systems and databases that handle big data efficiently. For example, a data engineer at a healthcare company might design and implement a data pipeline that collects patient health records from various sources, cleans the data, and then stores the data in a centralized database. They might also develop APIs for accessing the data and ensuring security and reliability. A data scientist, on the other hand, focuses on extracting insights and knowledge from data through statistical analysis, machine learning, and data visualization techniques. They explore data sets, develop predictive models, and generate actionable insights to solve complex business problems. Now, data scientists often use programming languages like Python or R and machine learning libraries to build models that can make predictions or classify data. Let me give an example. A data scientist at an e-commerce company might analyze customer transactions to identify patterns and trends in purchasing behavior. Now, they might develop a recommendation system that suggests products based on the past purchases or demographic information using techniques like collaborative filtering or natural language processing. Let's talk about the skill set of a data engineer first. Let me give you that. Data engineers typically have strong skill set versus software engineering because database management architecture, right? They are proficient with programming languages like Java, Python, or Scala, and have experience with distributed frameworks like Hadoop or Apache Spark. They also have knowledge of SQL and SQL databases, as well as data modeling and schema design principles. So whereas data scientists have expertise in statistics, machine learning, and data analysis techniques. Now, they're skilled in programming languages like Python or R and have experience in data manipulation and visualization libraries such as Panda, or for example, MATLAB. Now, data scientists also have a strong mathematical background and are familiar with algorithms like regression, classification, clustering, and other machine learning tasks. Now, in terms of workflow, how do they actually work? They're involved in the early stages of data lifecycle, focusing on data ingestion, transformation, and storage. Now, they work closely with data architects and infrastructure teams to design scalable and efficient pipelines that meet the organization's needs. Data engineers also collaborate with data scientists, by the way, to ensure that the data they require is available in the right format and accessible for analysis. The data scientists, on the other hand, they're involved in later stages of the data lifecycle, focusing on data exploration, modeling, and interpretation. They work closely with business stakeholders to understand their requirements and then define project objectives. Data scientists also collaborate with data engineers to access and pre-process data, but their primary focus is on applying statistical and machine learning techniques to extract insights and generate value from the data. So, while data engineers focus on building and maintaining the infrastructure for data processing, data scientists focus on analyzing data to extract actionable insight and build predictive models. Now, both roles are essential for organizations looking to leverage data-driven decisions and to derive value from data assets. Let's now delve deeper into specific use cases so you understand in more clarity. So data scientists focus on analyzing data to extract actionable insight and build predictive models, for example, right? Both roles are essential for organizations looking to leverage data-driven, but use cases for data-driven engineers, on the other hand, is pipeline development. Now, let me give you a scenario. A retail company wants to analyze a purchasing behavior to improve marketing strategies. Now, the data engineer role is basically designs, implements a data pipeline that collects transaction data from various sources such as POS systems, online sales platform, and customer databases. They also ensure that the data is ingested, cleaned, and transformed into a unified format before storing it in a data warehouse for further analysis by data scientists. So data streaming, for example. Let me give another example. Social media platform wants to analyze user engagement in real time and provide recommendations. Well, data engineer's role basically builds a streaming data pipeline using technologies like Apache Kafka or Apache Flink to capture and process user interactions as they occur. They also design scalable, fault-tolerant systems that can handle high volumes of data and deliver real-time insights to data scientists for immediate action. Data warehousing. Let me give another scenario. A financial services company like a bank needs to consolidate and analyze data from multiple sources to detect fraudulent transactions. Now, data engineer's role basically designs and implements a data warehouse architecture using technologies like Amazon Redshift or Google Query. They optimized data storage and retrieval to support complex queries and analytics that are performed by data scientists, while ensuring data security and compliance with regulatory requirements are in place. Let's now delve into use cases for data scientists, right? Predictive analytics. Let me give you a scenario. Same example scenario, an e-commerce company to optimize inventory management as part of the supply chain operations, right? So here the data scientist analyzes the sales data, market trends, and external factors such as weather or holidays to build predictive models, algorithms and machine learning. They also develop time series and forecast models to future sales volume with high accuracy, enabling the company to make informed decisions with inventory stocking levels and distribution strategies. The customer segmentation is also another area. For example, a telecommunications company wants to identify a distinct customer segment based on usage patterns and demographics. So a data scientist role here basically performs exploratory data analysis to uncover patterns in the data and correlations in the customer data. Now, they use clustering algorithms such as hierarchical clustering, for example, to group customers into segments with similar characteristics. Now, these segments can then be used to tailor marketing campaigns, pricing plans, and then customer retention strategies to meet the specific for each group. Natural language processing is something also data scientists work with. So, for example, a healthcare provider wants to analyze patient feedback from online reviews to identify sentiment, right? Now, data scientists here basically applies NLP techniques to process and analyze unstructured text data from online sources, such as review websites or social media platforms, right? Now, they use sentiment analysis algorithms to classify reviews and positive or negative or neutral, and then topic modeling for part of the allocation to identify key topics or themes discussed by patients. Now, this information can help the healthcare provider or the company identify areas of improvement and then enhance patient experience. Each of these use cases, by the way, data engineers and data scientists that I've talked about collaborate closely to leverage infrastructure and analytics technique to address business challenges and drive value creation. While data engineers focus on building and maintaining the underlying data infrastructure, data scientists focus on extracting insights and knowledge from the data to inform decision-making and drive business growth. So there you go. I hope this helps. Let me know if you have any questions. Comment down below which area is better, data engineering versus data scientist. I hope I've given you a clear picture between the two roles. Let me know if you have any questions. Thank you for watching. I'll see you guys next time.